Hi everyone, welcome to this supplementary video. And this supplementary video is focusing on use of Bernoulli's theorem for a network of pipes. And the idea is to just give you some practice for how to apply Bernoulli's theorem while also using continuity equation. And this problem would be especially useful for homework 3 problem 1. So you will get some additional practice through this supplementary video. So I just want to start something with a very basic question is, we have been given that there is only one pipe, that's just pipe P1, and we've been asked to calculate P2 and V2. Okay, and the Bernoulli's equation is valid in this case. It has been also given. So note that Bernoulli's equation says that P1 plus rho V1 square 2 plus gamma Z1 is equal to P2 plus rho V square 2 plus gamma Z2. Okay, so what we have to find is P2 and V2, and we have only one equation, which is the Bernoulli's equation. But don't forget that we also have the continuity equation, which says A1 V1 is equal to A2 V2, right? So first thing, it's pipe, and it doesn't say that there is any gravity, sort of we are not changing the height of the pipe. So this sort of goes away, right? And then we also are given that it's the same pipe. So the area of cross section is also similar. It's that we're not bending the pipe, it's just a straight pipe. So it's A1, it goes away. So V1 is equal to V2. And if this implies that V1 is equal to V2, and if we substitute this in here, we get P1 plus rho V1 square by 2 is equal to P2 plus rho V1 square by 2, because V1 is equal to V2, and so basically we get P1 is equal to, P1 is equal to P2. So basically the point being that in just a single pipe, if you're just flowing with a constant cross-sectional area, velocity doesn't change, and that's why the pressure also doesn't change. And sometimes students get confused here, and because intuitively the thought process is, well, the pressure should change because I'm flowing something. There should be some pressure difference. But remember, we are in Bernoulli's equation, and so we say that we are in system where we neglect viscosity. So whenever Bernoulli's equation is valid, you don't have to think. Basically, there will be no pressure drop if the cross section remains the same and the height remains the same. We cannot have any pressure drop because, again, we are not thinking about flowing. This is an idealized system where we don't have any viscous effects or viscosity effects. And in the later part of the course, we'll learn how to do this for a more complex system. Okay, but for now, just remember that in Bernoulli's equation, V1 is equal to V2 and P1 is equal to P2. All right. So the next question I wanted to do, this was more instructive for your homework, especially, is you've been given sort of this now 3 pipe network. In your homework, you have 4 pipe network. And you have been given that one pipe is sort of, there is some pressure and we're flowing. These are all horizontal. So again, there is no Z variation. So think of them like just lying on a table, for instance. And the question is, and you've been given also that A1 is equal to A2 is equal to A3. So this has been given to you. So let's imagine that. And the question is simpler. It's not actually trying to solve anything, but is asking you, is P1 is equal to P2 is equal to P3? Oh, sorry. Yeah. So that's the question. Could P1 is equal to P2 is equal to P3? Okay. And so this has been given to you. Now, remember that whenever you're applying Bernoulli's theorem, I think in this problem, because it's obvious, we are kind of applying it, in the flow directions. And so let's apply, and we say rho V1 square by 2 plus gamma Z1 is equal to P2 plus rho V2 square by 2 plus gamma Z2. Okay, and then again, this goes away. We can also apply this from 1 and 3. So you can use combinations as well. So P1 plus rho V1 square by 2 is equal to P2 plus P3 plus rho V3 square by 2. And note that I'm doing it in the direction of flow, and just sort of be consistent. I do this in the direction of flow always to get sort of consistent answer. And I have just note plus, if you want, you can also write plus gamma Z1 plus gamma z3. These are same because the same height, or you can assume z to be 0 simply. And so we get this sort of P1 is equal to rho V1 squared 2 by 2 plus same for P3. And then we also have now continuity equation would be flow in is equal to flow out. So we'll say A1 V1 equal to A2 V2 plus A3 V3. Okay, and this is an important part. So remember that here we don't have two ones, we have in and out. So in, and this is out 1 and out 2. So this is a slight difference. That's something that you have not seen before. Is now because we have some flow rate coming in and it's kind of distributing in two pipes. So I have to sum both of them to get to the right sort of expression. So we get this, and we have been given that V1 is equal to A1 is equal to A2 equal to A3. So this implies in this case V1 is equal to V2 plus V3. Okay, so that's what we have been given. Now, how do we go from here to what the question is asking? The question is saying could P1 is equal to P2 is equal to P3. Okay, so question is could P1 equal to P2 equal to P3, right? If that has been given to me, then let's assume that is the case. Let us assume that is the case. In that case, basically so substitute this, so you'll get P1 plus rho V1 square by 2 is equal to P2 plus rho V2 square by 2. And if that is the case, then this goes away, that this implies V1 is equal to V2. And then P2 plus rho V2 square by 2. Sorry, not P2, P1 plus rho V1 square by 2. P3 plus rho V3 square by 2. This is the second equation. And if I substitute again, P1 is equal to P2 is equal to P3, this would imply that V1 is equal to V3. And if this is true, then I cannot have this to be true at the same time, right? I cannot have this to be the true at the same time, because V1 also is supposed to be equal to V1, V2 plus V3. And that's why this situation is not possible, because if P1 is equal to P2 is equal to P3, then I don't satisfy Bernoulli's and continuity at the same time. So this system is over specified, or sort of cannot be balanced in that way. So that this situation is not possible. Not possible. However, if I basically get some different combination of areas or something like that, it is probably possible. But in this particular case, we cannot have V1 is equal to V2 is equal to V3 and still be able to kind of get essentially the get the answer. Okay. And so I think that's it for this video. I just wanted to show you kind of an example. What you would basically in your homework problem, you have 4 pipes. So you will write these 3 times, P1 to 4, 1 to 2, 1 to 3, 1 to 4, and something like that. And you will be having, output of flows to kind of in and out in terms of flow rate. And then you will just be manipulating and putting in values to get the answer. So hopefully this gives you a flavor of how to use network of pipes and use continuity equation. So take a look, and if you have questions, feel free to reach out. And I look forward to seeing you in the lecture.